Sljedeće predavanje je Robert Veždaver, pričat će o postavljanju vlastite platforme kao servisa uz pomoć ovih poznatih alata. Robert, možeš početi.
Do I need to do this in English, or do you want me to, can I do it in English? Sure. Yeah, just in case I don't know the people here, so. Hello, boys and girls. So my name is Robert. That's my Twitter handle because, you know, that's like the hipster thing to do, is put on a Twitter handle, and you can actually find me on GitHub there as well. And I'm going to talk about building your own platform as a service with Mesos and Chef. So what I do, I'm officially a site reliability engineer, whatever that means. They also call us DevOps because that's a buzzword. It's like for people who are not really good enough to be a developer, nor really good enough to be ops, so you know you become a DevOps. And there's actually a twofold reason on why I have this picture behind me. One of them is because that's actually where I come from. So this is, you know, for those of you who know Croatia, this is the picture taken from Učka, and that's Istria over there, and I come from like there, somewhere. The second reason is actually more professional, and it's actually a metaphor for what I'm trying to achieve here. And this whole kind of fog here, this is what I want my developers to see. I don't want them to think about the infrastructure. I don't want them to think about how their application will be, you know, will go inside a load balancer. And I certainly do not want to think about them using resources of entire nodes just for like a Ruby app or something like that. So this is what we want to do. I will, you know, I could talk about myself, but that's about it. I'm here to solve problems, so I'll give you a little bit of context. I currently live and work in Paris, and this is also like, you know, a kind of a nice introduction to put the Eiffel Tower there, you know, city lights and all of that. And I work for a company that's an ad tech company. We're called Cridio. You've probably never heard of us, but we're actually we're not small. You know, it's around 1,800 people, out of which 300 engineers. We're always on the lookout for new people. You know, so if you're interested, please, you know, do tell me. And we have around 1 billion users, basically the entire internet. So now this is where things get a little bit kind of complex, because we have 17,000 physical nodes in 7 data centers around the world. We have the largest Hadoop cluster in Europe of 40 petabytes of storage. We get up to 2 billion HTTP requests per second, and each of those has to be answered in less than 50 milliseconds. So we have some issues from time to time. It's a very big team. You know, we're organized. I work in the team that's actually responsible for, I won't say building the platform, because, you know, you have several teams. You have the guys who go there and actually rack up the physical nodes. You have, but basically once you put the machine in and you boot it up, and up from the Pixie boot to the application deployment, that's where our code comes in. And we manage this via Chef. And we're not the only team that does this. We're like the core team, so we provide like, you know, RAID configuration and stuff like that, all managed via Chef. However, for example, we have a Hadoop team which only kind of, you know, work on Hadoop recipes, recipe being a Chef module, if you will, that actually configures the Hadoop cluster and stuff like that. So it's kind of a cool workplace, actually. And after a while, you kind of understand that if you really want to scale, it's very, very, very difficult to scale just with traditional DevOps tools. And by traditional DevOps tools, I'm talking about, you know, Chef, I'm talking about Ansible, I'm talking about Salt Stack. You know, after a while, you kind of go and you think like, this is not fast enough. This does not, you know, scale. Not only does it not scale in kind of machine size, that's actually the easy problem. It doesn't really scale in team size. Because after a while, you know, you get these, well, French developers who, of course, you know, complain in French, like, oh, putain, le mec, je peux pas. Alors, so basically, you know, they come and they complain and they say, well, you know what, I want to test my app in pre-production and I have to wait for you guys to, you know, bring up, I don't know, 10 servers and stuff like that. And I want to do it like tomorrow. I don't really want to wait on you to actually code all the stuff that's necessary to bring it up. So, so we thought about it, and there's this really cool new thing that kind of solved our requirements, which were basically we wanted to have, we have mostly stateless applications, because we also have like a relatively large Couchbase cluster, and so we kind of keep the state there. We have some, you know, relational databases and stuff like that. However, one of the things that, you know, were kind of mostly required were programs that were stateless, that were written in Java, so basically that could run on Linux, which is nice. We also wanted the whole kind of system to be self-service. So we basically wanted a developer to come and to click like, oh, I want a new application, and then it will deploy how many instances they want. So we kind of built a private Heroku, if you will. And of course, you know, you try to optimize the system, but that's that wasn't the biggest requirement. So we already have a Chef pipeline. We push everything to Git, and then every single merge request has automated tests. And I don't know how many of you do Ansible or Chef or SaltStack or Puppet. However, if you do that, please test them. And by testing, I mean, you know, you can have unit testing, you can have functional testing, you can have integration testing. For example, we've actually managed to find out that one of the functional tests that we have done in Chef was building a multi-DC console test where you bring up like 3 masters in Paris and 3 masters in New York, and then you kill both leaders at the same time, and according to the docs, this should work. It doesn't, at least not in version 0.5. And then it kind of fixed that bug. So, you know, never trust anyone, especially not documentation. So, you know, we have the Chef deployment, and it's nice. And what we wanted to do is wanted to use what we already have and then build on top of that. So we've decided to try out Mesos. Now, Mesos has a relatively simple architecture, kind of. So it uses Apache Zookeeper for leader election. And you can have a number of leaders from, you know, 3 to n for high availability purposes, and it's always one master that's selected. And then you have, you know, just a cluster of slaves that have a small kind of supervisor, if you will, that launches jobs and tasks for you. Now, this is the trick. The trick is that there's always one Mesos master that's active, and the other ones are on standby, and they have kind of a replicator log. So basically, whenever you want to launch anything in a cluster, what you do is you go to the Mesos master and you say, hey, I need some resources. You know, it offers me some resources. And then I say, you know what, I'll take these resources and I will launch something on you. And then it does that for you. And it launches that on slaves. So think about it as the kernel of a distributed clustered operating system. And on top of Mesos, because Mesos is actually kind of, well, silly on its own, because it doesn't actually do anything useful. You have to have frameworks. So you can have several frameworks. Aurora was built by Twitter and Airbnb. Marathon Kubernetes, I don't know, maybe some of you have heard about Kubernetes. It's from Google. And this is what they call a 2-level scheduler. So you have Mesos, which is responsible for the whole bin packing resource management algorithm, which offers resources to the frameworks, and then the frameworks, which actually, you know, take the resources, have a kind of algorithm to schedule the tasks on top. And this runs on any given slaves. It's isolated. It's actually pretty nifty because you can isolate by CPU, memory, disk, and even network resources. So you can actually say, oh, you know what, I'll give this app only 100 megabits per second, and then the other ones will basically, you know, get resources based on if they need more or less of network resources. After a while, you also kind of figure out that, well, okay, I have all of these tasks and all these slaves. However, what I really need to is actually load balance between them. So for that, well, at least for marathon applications, what you can do is, you launch a task, it gets, started on a slave, and then it actually calls a thing called Bamboo, which then reconfigures HA proxy. So what happens is, a developer comes and says, I want application A, and he or she launches application A on, say, I don't know, like a small number, like 30 or 40 instances, and then all of these 30 or 40 instances automatically call back Bamboo, like the deployment calls back Bamboo, but then that reconfigures HA proxy, so you have automatically 40 instances on different ports going through the HA proxy load balancer. And this actually works pretty nice, and I'll actually show you that because most of the presentation is about the demo. And after a while, we made a shopping list. So we kind of started small. This is already going to grow. We currently have 7 load balancers with 3 Mesos masters, because you can put like Zookeeper, Mesos master, and the framework scheduler on top on one server, and we have 50 Mesos slaves. This is per data center. So that's 7 times 50. So it's a nice little thing that we're going here, and you wouldn't believe actually how developers love that, because what they only need to do is they really need to click around, and their application is in pre-production, and they can do whatever they want, and they can actually deploy it whenever they want. They even have like several orchestrated deployment modes that they can use, and it gets picked up by the load balancer, and they don't have to care about anything. They don't have to ping us, they don't have to ask for resources, everything is there, and it was really incredible once we started, and kind of the support that the team has shown. We even managed to kind of convince some people not to do code in C# but in Java. So, if you want to build this yourself, all of the layers may be built by Chef. We do this. So the Marathon cookbook, Mesos cookbook, Apache Zookeeper cookbook have been somewhat either rewritten or kind of partially rewritten by us. So we really wanted to do this like the proper way. We really wanted to do this in the open source way. So we've rewritten both the Marathon and the Mesos cookbook. And for the Zookeeper cookbook, we've actually added ACL support, so you can actually secure your Zookeeper installation. Kind of secure anyway. And we even wrote a cookbook for Bamboo so that you can deploy it and it will automatically connect to Marathon, it will do the whole callback thing, and it will reconfigure HA proxy. So if you want an all-in-one solution with Ansible, though, please do check out Mantle. They're actually a pretty cool project. And what they do is actually, they're a Cisco spin-off where they configure Mesos and Consul and Zookeeper and even like HashiCorp's vaults and all of those kind of nice things for you. So check that out. Of course, once you actually run the system, you will have to plug it into other systems. So on every Mesos slave, we have an rsyslog daemon that actually then sends data to Elasticsearch. We have Nagios for for probes, and then of course every single Mesos slave has a collect D daemon that gathers metrics and then sends that to Graphite. So this we already have, all of this around we already had, and then we just kind of plug the system in. Every single slave also has, every task is also then plugged into Consul, so you have auto-discovery for your tasks. And for example, you don't actually need to have only one framework, you can have multiple frameworks on. So we're currently working on migrating Kafka to Mesos. So we don't have kind of a separate cluster for that, but just have it on the Mesos cluster. And everything is authenticated via Microsoft Active Directory, believe it or not. And of course, managed by Chef. So, now that you're all kind of confused and are not really sure what I'm talking about, well, let's talk about running. So, what I will do is I will show you a Vagrant file. so what I'm doing here is I will start 3 CentOS 6 boxes, right? The first one will be a master, and I will configure it via Chef, and I will tell it to run Zookeeper, Mesos, and Marathon. The absolute same configuration that I've shown you on the slides. You're just going to define the Mesos and Marathon version. And then I will configure 2 slaves, slave 1 and slave 2. The only thing that I have configured in this is the Zookeeper endpoint, because Zookeeper actually knows where my Mesos masters are. So what I say is, okay, a given slave will connect to Zookeeper, we'll find out the Mesos master, and then it will go from there. And this is Mesos. I have a cluster that has 2 slaves, 2 hosts, 1 CPU, 200 something megs. I can check out the log of the slave. I can check out the frameworks that are currently registered. As you can see, I already have a Marathon framework. And then I have Marathon. So this is what the developers see. And this is what they like. So if I want to create an application on my cluster that is currently running on this computer, I will just go, click here. Let's say I need 0.1 CPU and 32 megs of RAM with 10 megs of disk. And let's have an example here. So I suppose everyone knows what this does, right? It's a bash loop that will just output hello world. Well, hello Marathon. And then I will say that I want to run this with the root user because I haven't configured users on my virtual machines. The moment of truth. So I have a task that is running, and this is it. Wow. Oh, good, wonderful. Sorry, that's actually the web UI that doesn't work. So what I have here, I have one task that is running on one slave, and if I go to the Mesos interface, I can actually go to the slave, to the framework, and check out the task and check out the sandbox. And let's say I want to see the standard out, and this is it. This is my task. This is running. And let's say I have some issues, I don't know, and I want to scale to 5. And I'll just scale to 5. And now I have 5 applications running on my slaves. Or maybe, 10. Just for the fun of it. And now I have a small cluster of applications that run. So this was kind of nice, It's a bit useless though, because it doesn't actually do anything except print out hello Marathon, which as interesting as it may be, it's not really the coolest thing in the world. So let's start something different. Let's start a Python application that will actually that will run an HTTP server on port 0. So port 0 is special. Marathon will actually automatically and dynamically give a port to this application. That will, of course, run as root because, again, I did not set it up. I have to put a dot here. Wonderful. So now I have 5 applications running on my cluster, each of them having a sandbox. So I can just go to the sandbox, I can see the STD out. So you can see that it only started, you know, what I said there in the command line arguments. And I can go to any of these and it will do a directory listing, because that's what the simple HTTP module does. Now the cool thing about Marathon is that I can actually do whatever I want, because I have a JSON mode, and actually all of this is actually a simple post JSON that the developer just sends. And it works, and it will actually deploy how many applications they need, and they can even configure health checks, either HTTP or kind of a command line, so that they're sure that their app is always online. And Marathon will actually do automatic orchestration for you. So for example, when it deploys something that has a health check, it will deploy an application, it will check its health status, and only then it will continue. So when you have the kind of, when you have an upgrade, what you do is you actually, for example, take out 50%, you'd redeploy the new version on 50% of nodes, and then you do that again. Or you can do it in like 30% or whatever you want. And of course, you can put any environmental variables. These are like the standard Linux environmental variables that you want. We had to do two workarounds here. The first workaround was logging. So we kind of did a task executor wrapper that will actually send out all the SED out and standard error logs to, what was it, Elasticsearch? And the second one, which we had to do, was secrets. So what we do is we give developers, we give a team a public key, and we tell them, you can encrypt any secret you want, any environmental variable you want with this private key, and we will automatically, actually detect this in our executor, and we will actually decrypt it with the private key that has been put there beforehand with Chef. So that's the only kind of link we still have with Chef. But this is something that is actually a feature request in Marathon, so we're trying to do that. And of course, if you really want to, you can put Docker containers there as well. So Mesos is about to support both Docker and Rocket containers. I would not advise you to play with Docker in production right now, at least not in this state. I would advise you to wait a little bit for the Docker image support and Rocket image support in Mesos. So you don't have to kind of have so you don't have to have another component that will actually, the Docker daemon that will actually run your containers and stuff like that, but you can do this all inside of Mesos. So that was a very, very short overview of Mesos, Marathon, and how to build it. So I think I've mentioned we're hiring. And question time.
Baš sam htio reći, niste valjda toliko umorni već.
Hello. How do you let your developers to boot tens of machines? Did you have any troubles with those? Because they could probably use all the resources available.
Oh yeah, no, we give them, so what we do is we give them free access to pre-prod, and they regularly break it. Like, it was really funny when we started this. They kind of decided that, well, you know what, I'll just turn on debug mode, and I won't put any limit on disk space. So that was fun. But no, we give them access to pre-prod, and you have kind of you have an Apache reverse proxy in front so that it authorizes them to deploy applications. However, for production, they have to go through the whole Jenkins pipeline, and we have the so-called escalation or Q&A team that actually checks that everything is in line with what they actually need. We have also developed probes in so basically, because we send metrics to Graphite, we can actually see the difference between the actual utilization of the application and the resources that they have reserved. So we are thinking of buying a gigantic baseball bat and, going from developer to developer just to see if they're kind of, overutilizing the cluster. Any more questions? Run, Forrest,
To
run.
se računa kao trening.
What were your reasons for choosing Chef?
Pardon?
What were your reasons for choosing Chef?
Okay, so that was mainly historical, actually. We tried using Puppet, and then we kind of switched to Chef because Chef had better Windows support, because out of those 17,000 machines, we still have 5,000 Windows servers because of legacy reasons. So that was the main one. However, we're actually pretty fine with Chef. We do like it. We've you know, from time to time we kind of check out Ansible and stuff like that. And remember, Ansible didn't even have like proper, you know, it still doesn't actually kind of have proper unit testing and stuff like that. And Salt Stack seems cool, but still a little bit in its infancy. So for now, we're kind of, you know, pretty happy with Chef. And it also actually scales pretty well, you know, especially if you run it on a physical server and you just, you know, give 16 gigs of RAM, just, you know, there you go.
Okay, no more question. Thank you very much, Robert.
Thank you.